Okay, this is TempleOS 5-minute random code walkthrough, episode 29, and I'm your host, Terry Davis. So let's see where God takes us. We got taken to graphics init. Okay, I do all the graphics routines myself, and this routine initializes the graphic global variables. We can talk about the global variables. 28-bit is a, let's see. Two 8-bit is an array that's used for converting. I think it's full of 000. It's full of 8 zeros, then 8 ones, then 8 twos. So if I say dump gr 28 bits, no, that's not what it is. Oh, it's 8 bits together for where there used to be a 1-bit. 8 bits together where there used to be a 2-bit. A 3-bit is FF. Okay. These are used as masks in... we have to convert between 1 byte per pixel and 4-bit planes with 8 pixels per byte. Anyway, that's 2 8 colors is now it's going to be okay, 0001112223333. Okay, so when you combine a mask made from these bits with a color made from these bits, you can generate you can work with 64 bits at a time, 8 pixels. Anyway, okay. So those are utility arrays used in some of the rendering. Text base. This is I use 32 bits per text location. What that is it's the ask. Let's see if I can find. Oops, that's not what I wanted. So bits zero. There's 32 bits for each text character. The low 7 are the ASCII. Then it's the foreground, background. Then it's we have subscripts and superscripts allowed. So when I say sub toggle, I just did you see? No, I just made that to a subscript. Anyway, when we have this up at the top here, this marquee, that's done with X shifted. Then we have Y shifted, and then we have blink, invert, selected, underlined. So those are the bits for each. Now you don't normally deal with that. You don't really have a good reason to mess with that. I don't know. Normally you let the document structure do it. Anyway, so text VGA text cache. When we're operating in the kernel panic, then we have a monocolor. What is this? VGA text cache. Oh, that's kind of strange. We can run in text mode. Okay. That's. Do I cache B800 memory? I don't think so. I don't know what this is. It's not important. That's for text mode or kernel panic, one or the other. Win uncovered bitmap. This is what is this? Win uncovered bitmap. I don't know what that is. Highest uncovered. WinZ buffer. WinZ buffer is if we go to graphics mode, there's a routine that shows the Windows Z buffer. Here it is. Okay, so we have two windows. One. Now, if I move it down, we have three windows: red, purple, and cyan. So that's the WinZ buffer. So the Windows Z buffer keeps track of that. Okay, these are the main rendering bitmaps. There's a persistent layer, which if I say gr circle DC grdc1, I think that's persistent. Not is 2 persistent? I think 2 is persistent. grdc2 100. No, it's 0. It's 1? I don't think it's 1. What? Let's hold on a second. GRDC is persistent. Okay. GRDC is persistent. GRDC2 is the, I think that's the one refreshed all the time. Then when you do a zoom, Control-Z, there's the zoomed and the unzoomed. That's down here. Screen image is what we actually send to the. Mostly we work with 8 bits per pixel. We work with a byte per pixel, but then when we get ready to write it to the memory, the graphics memory, we have to convert it to 4-bit planes. So the screen image is 4-bit planes. I think so. Anyway, so those are the what is 1 and 2? One of these, DC is persistent, and let me explain. The best way to explain it is to go into the graphics. The window manager updates the screen 30 times a second, and each time it updates, it draws the text layer. That's that 32-bit thing I talked about at the beginning. It draws the text background, the text foreground, then it updates all the task windows, then it blots. GRDC this is the persistent layer. There's a layer for persistent graphics put onto the DC2. The text layer, it starts fresh 30 times a second, and then finally we put the mouse cursor on. Then finally we change to 4. Wait, where do we zoom? Anyway, we changed to from 8 bits per pixel to 4 bits per pixel, separate planes, and then we update the memory with caching. There's a cache for for the memory. We don't want to the graphic memory is slow, so we only do what's changed. Anyway, let's go to update Windows. Now this goes through all the tasks on Core 0, starting with the window manager. They're in Z buffer order, and it calls update the documents for the task. That's the client, and the border is a document, and the main window of the task has a document. Then we call the drawback if you define a drawback, so that gets placed on top of the and if the document has graphics, those get updated here onto the fresh graphics layer, DC2 I think. Anyway, and so it goes through all the tasks on Core 0. Okay, well anyway,